So we want to open with some sort of general stuff about industry. We have some disclaimers to make, and then move on from this. And then each of us is going to talk about our own experiences, which may differ. I worked, so did I did my placement at Sellafield Limited. We're going to explain what these places are. If you haven't heard of them, so don't worry. Raghav at JLR and Tüge at the Technology Facilities Council. And we're each going to sort of try to address the sort of general points on placement and try and give you sort of what you need to know. And then we'll sort of bring in some closing remarks and take questions after we've all done talking, because probably will end up covering somewhat different things. So on general stuff, the first thing is that we are talking about our own experiences. None of us are experts, and there is no sort of template for placement. It's very, very different based on who you are and where you go and how you behave on placement. So, you know, at your own risk. None of us are experts. There are experts for this that you should speak to. The career service in particular, and also some schools have specific people. I don't know who that is for physics and maths, but for triple E and comp sci, maybe are, and you should reach out to them. They know more than we do, and are more able to give you proper, good, tested advice. The points we're trying to cover from each of our talks in our own different ways will be the process of applying, which is horrible. Sort of what you can expect, so the kind of work we did, what you know, insofar as you can expect anything, what you can expect, and whether it's worthwhile and what we feel we got out of it or didn't. So I'm gonna start with my bit, I guess. Try not to bore you too much. So Sellafield is the premier nuclear waste facility in the UK. At various times in its life, it has been an experimental research facility, a weapons development program, a civilian nuclear reactor, and a waste-free processing facility. And now it's where all of the nuclear waste in the UK lives, all the weapons grade material and everything else. I was on the remote handling equipment program, where I dealt mostly with that side of the logo. I'm not so into the mechanical side of it. And we were sort of premier high technology readiness level problem solvers for site. So I'm going to talk about applications first. I feel, and again, this is my experience, and Tüge and Raghav's experience may differ, and your experience may differ, but I felt there was a trade-off between how specific you wanted to be in what you wanted to do versus like how easy it was to actually get a placement. So robotics is niche, I think a relatively small niche, and there are few companies who specialize in robotics only. And of those that do a lot of stuff, they will probably have a robotics team, but they might not be taking placements on that team. So if you nail yourself too closely to a very small niche, then you will struggle. At least I struggled. It's easier to get placements if you are broader, but then you risk applying for jobs you don't actually want. So bear that in mind. You have to make the trade-off yourself. It's likely that your CV is not good. My CV is still not good. Especially if you haven't applied for like a professional engineering job before, which I'm assuming you probably haven't. Talk to the career service, at least in Triple E, and I suspect in other departments. They ran a kind of CV surgery thing where you could take your CV to them on a piece of paper, and an expert would go over it with a red pen and be like, this is terrible, this is irrelevant, you should add this, etc. And I did that several times over several revisions, and it improved the application process significantly. So please do that. Don't try and figure it out yourself. They're the experts and the best to advise you. You should have already started applying for placements. Sorry, that's scary news. They go fast, and there's lots of competition, especially if you're doing it between second year and third year. You're competing with people who are doing it between third and fourth, who essentially have a bachelor's under their belt already. So it's hard, and you have to do it fast and early. Sorry. That was the standard I went with. 1 or 2 companies every week for all of the first semester. We are now halfway through the first semester, so if you haven't started applying yet, you might want to do more than that. I don't know about how your experience will differ from mine. I went for ultimate niche. I was clear I wanted to be a roboticist, which made it hard. and I had to apply for 32 different placements before I got one acceptance. You might be better at it than me, admittedly. It took me a long time to get a good CV and figure out how to do interviews and stuff. And if you're going for electronics more broadly, then you probably have an easier time, but be aware. They don't stress this enough, I don't think. Write a custom CV, not CV, cover letter. CV can be the same, but the cover letter should be unique. It indicates that you actually know what this job is and you actually care about it, which is especially important if you don't and you're applying to a million places. You don't want them to know that. You want them to think that your application for them is special and unique and you're uniquely driven to do whatever it is that they do, and you're not just applying for it because it's, you know, week 9 and you still haven't had any interviews and you panic. And get ready for the rejection. I've already leaned on this point, I guess, so I'll stop leaning on it after this. But yeah, it's a process and it's not fun, and we all do it, and it'll be fine, I guess. We survived. That's the end of my complaining now. This is mostly going to be fun. So I was high TRL robotics deployment. So Sellafield has a bunch of really old buildings containing really old hazards, and they don't want to send people to them anymore. Some places still do that, but the UK government doesn't want to. So robots. But they've only really made this push quite recently. The placement culture app site is very sort of, sorry, I'm going to be saying site all the way through this. I mean, read Sellafield, is very sort of get involved. Their placement structure is very loose. You apply to be, say, an engineering and maintenance placement student, and then you can work anywhere in engineering and maintenance, which is huge. And you just kind of have to ask. A lot of placement students do 3 or more different parts of the company, and they're vast and different from each other. And that their program specifically provides a lot of opportunity for freedom. I didn't take it. I really liked my job, so I just stayed in that team the whole time. But Ari, what I did, so technologies, advising the business, piloting some ROVs, etc., etc. These were all the fun bits, and I won't lean on too much because the day-to-day was not like that. But there's a new way to do interesting things, at least at site, presumably elsewhere. Having done the interesting bit, the actual day-to-day is more like this. So we would get a request in from someone on site. You know, there are more than 1,000 buildings on site. They're all doing completely different things, between like managing the weapons grade material to making the energy stuff safe to like, we're pulling stuff out of this pond and we have no idea what it is and we need a robot. They would come to us and ask for help. We would work with the client to understand what their problem was, what their needs were, try and figure out what appropriate tech already existed to solve that problem, get some of it in, do some tests, introduce it to the client, see if they like it, etc. Issue a recommendation finally to the business to say, this is the tool to solve this problem. Oversee its deployment onto site, which could be challenging. If you were deploying, say, UAV to perform inspections inside cell, the cell deployment hole is 100, I think it's 15 centimeters diameter. So it can be quite challenging, the deployment side of things, especially in nuclear environments. Train any client staff, if needed, in how to pilot or use whatever they have, because they probably aren't roboticists on the plant. Execute any operations. So sometimes that would be, say, we need to know if this thing is, how radioactive it is. Shrug. And it's at the bottom of a nuclear fuel storage silo that hasn't been opened in 40 years. And delicate operations like that will be handled by the robotics team, who are trained pilots for their R&Ds. Problem solved for it? Shrug, probably not. Knowing how these things tend to go, it's more like in the process of solving this problem, we have created or identified 3 new problems. But that's what the actual day-to-day is like. There was fun and interesting stuff. I will talk about some of it later, but this is day-to-day. Bear that in mind, because 80% of what you do won't be free. That's just how work is. I was also a field operative for my team. This is the fun bit. So in order to do a good job of solving problems, you need to know what tools actually exist, right? And my job for the team, my specialism was keeping the rest of them up to date. So keeping up to date on what's happening in the industry, what's happening in research, et cetera, et cetera. What are, we don't really have competitors, but what other nuclear sites in other countries or parts of the country are doing. I go and visit those places. So I went to a lot of unveilings, tech demos, conferences, etc. It's good fun. That was the best part of my job. Two or three a month, usually. Write some massive report, irritate my hosts who were kindly providing me with lodging and food by asking difficult questions about the nuclear industry that they want to know about. And then go back to site and more often not tell them why this tech isn't useful and sometimes what it might be good for in 5 years. And yes, that also means understanding all the problems on site. So how do you know if a piece of technology you're looking at is going to be useful on site unless you know all the problems? So most of my time actually day to day when I wasn't doing the process I just described was meeting with people who had many disparate problems, most of which I had nothing to do with solving. And occasionally it was like, oh, maybe this matches to this problem we've heard about. So two examples of that. This is the Cthulhu. Everyone called it Cthulhu on the day, but that's how it started. So I'm not calling it that. Which was a seabed crawler. So they were mostly interested in the oil and gas industry to keep an eye on pipelines and stuff. But they also invited Sellafield. They figured it could be useful in the nuclear fuel storage ponds, and it wasn't. And I had to, unfortunately, in my report, relay a conversation I had with the engineers about the fact that those tracks do not come off easy. It's tough to do. You need specialized tooling with your normal, not in a radioactive environment self, let alone in a massive puffed up plug suit. No, it would have been completely impossible to perform maintenance on this thing. So we ended up rejecting it, unfortunately. And similar problems with the Helios. The Helios is really cool, it's very good. The cage has 3 degrees of rotation around it, so the 3 axes complete. It's very cool. And I have flown it, so you can fly it directly into a wall and it generally doesn't break. It's pretty impressive stuff, but it's too big. The entry ports for the cell are 15 centimeters diameter. And Helios is way bigger than that. So despite it being really cool, we had to say no. And there's a lot of saying no in the nuclear industry. Yeah. Chartership, this is the last thing on what I did, and I think this is important, so I want to lean into it. Some places will prioritize chartership and others won't. Sellafield did, but you can do it anywhere, and it's well doable within a year. So there's 3 levels to chartership. Eng Tech is the first rung on this ladder. It's pretty easy to get, and it's a baseline of professional competency that'll be recognized by any company in the country. Incorporated engineer and chartered engineer come after, but generally you start by doing Eng Tech. So these are licensed out by the Engineering Council to professional institutions. So the IET is one, the IMechE is one, and there are a number of smaller ones. The Society is recently partnering with the Institution for Electronics, which is a much smaller version of the IET. All of these places can issue these kinds of qualifications. And it's absolutely doable to get Eng Tech in a year. I've seen people do it in 6 months. And it's well worth it because you can keep that qualification after the year in industry. And you do technically get postnomials. Nobody uses the Eng Tech postnomials because it's a little bit like bragging that you've done the easiest possible thing you could do. But you can technically do it. And yeah, as I say, so Sellafield really leaned into this and pushed all the placement students to do it, and we all did. But if your company doesn't lean into it, you don't need them to do it. You can do it yourself. The university tends to pay for your membership of a professional institution while you're a student, and that extends to your placement year. So I would encourage you to do it. There are lots of resources online to find about it. Well worth it, I think. My last bit, was it worthwhile? So placement is a year-long job interview. You're interviewing them and they're interviewing you. You will decide whether you enjoy the industry you're in or the industry in general. In my case, I felt that while there were good days, industry wasn't for me, and now I'm doing a PhD. But it's very common for placement students to get job offers at the end. Virtually everyone who worked at Sellafield got one. And many of those people are now back on site, earning graduate wages. They had that job offer all the way through their final year, and they could just sort of not worry about it. And that happens at a lot of companies. So I'd well recommend doing it if job security is a priority. I won't say it teaches, but it depends where you go and what you do and how you see the opportunities. But it taught me skills that you can't get in a lecture. So towards the end of my placement, though that big block diagram, I started overseeing little bits of that. But at the end, I was doing the whole process from beginning to end. And it taught me a lot of sort of confidence project management, like how to interact in the business environment. Like you start being like, oh, well, I'm a student and I'm out of my depth and I'm just going to defer to everybody and like kind of not step on anyone's toes. And by the end, it's like, no, yeah, I am a professional and I know what I'm talking about. And I'm going to tell you what's happening with the robots. And that's valuable. And you can't get that from a lecture theatre. And I've found that to be very helpful in my life, it delays your graduation by a year. And it can be hard to get back into studies afterwards. I don't want to speak for you guys. I don't know how you're finding it, but I found getting back into third year after my placement to be really hard. Like I'd forgotten everything from second year and I had to do it all again. And it was a nightmare. Like the first semester was an absolute nightmare clawing it back. It was worth it for me, but just know that going and sort of be prepared. It's less helpful if you go into academia, I feel, not unhelpful, but less helpful. I'm not benefiting from, say, the networking or the offer of employment I received because I'm doing my PhD now. I'm not working for Sellafield and I'm probably not going to work for Sellafield in the future. But it was still helpful to me. Like I still got those skills out of it, but it's definitely more helpful if industry is where you want to go. So, in all likelihood, you probably won't do it here. That's probably worth considering. The set of jobs available in the UK or indeed in the world is wider than the set of jobs available in Manchester. So it's improbable that you will end up here. And that's something worth bearing in mind if you don't want to leave your established social groups or routines. But it does pay you a bit of money, and that's nice. The fees are significantly reduced for your industry, which is lovely, and you are paid. Not an awful lot, at least in my case, but you are paid. And you know, I'd be remiss to not include that in the list of was it worth it. And for the record, before I stop talking, Sellafield's placement schemes close at the end of this week. So putting that out there, if you're interested in what I have just talked about, I did the engineering and maintenance placements at the top. They've increased the pay since I did it, but I'm not. Yeah, if you're interested, don't wait because they will close on Sunday. Okay, I think I'm done. We'll take any questions at the end if there are any. Do you want to go, Jude? Sure. I'll do it now.
Okay, so do it from here. Okay. Nice. Okay, I'm going to try and avoid some of the points that Daniel talked about, just to try and keep it so interesting to you guys. But some of these will end up overlapping a lot. I did my placement at the Science and Technology Facilities Council. I had personally never heard of this place before I applied, and then suddenly I found out that it existed. I wasn't too interested when I applied, but when I went for an interview, I was actually like, ooh, this is a cool place. And what it is basically, it's a, you can imagine that like CERN in the UK. They are a science campus with loads of, hundreds of buildings with different scientific experiments happening. They do things with satellite space. They send things to the ISS. At the same time, they have particle accelerators, neutron and muon sources, a lot of scientific equipment, but also do technology, for example, the detectors for CERN itself, or they are all over the place from what they do. Technology-wise, they did a lot of stuff with COVID. And basically what they do is they provide academics and researchers access to scientific facilities, big facilities. Again, that includes a neutron immune source, an X-ray source, and these things are big buildings, big machines, a central laser facility, and I'll talk about that in a second, and space facilities. So specifically, I did my placement in the central laser facility. And we're not talking about the kind of lasers that you have on the table. We are talking about the kind of lasers that take up an entire building. One of our lasers used to be the most powerful laser in the world until 2012. So we're talking about petawatts here. And again, it's all about providing access to academics to scientific equipment. You can basically think of it like microscopes, but I had actually nothing to do with that. These usually used for fusion and particle acceleration and materials testing experiments. But again, I never saw a laser until my very last day. Something that I didn't realize until working there was, in science, more than half the jobs are not scientists. They are engineers, actually the people who actually design these things, who run these things, who actually make all the science happen. Yeah, there's a couple of people actually then suggesting experiments and then trying to use it. But the vast majority are actually engineers who design these huge and complex machines. My personal group that I was working with was with the target fabrication group. And a target, you can imagine, is any material in any geometry, in any orientation. It's about the worst defined thing you could possibly have. You know, it was completely, this on the right is a target, that on the left is a target. It was really badly defined because every scientist would say, I want this type of target, I want that, I want this specific thing, and they don't know what we can do. So they'll just give us some random thing and say, design me this object and make it. And that would be our job. We would take designs from scientists and we would sit down with them and say, we can do this. And they want specific other thing. How about we can use this and we can make you a target. Now, this is actually one of the things that I came up with. The problem with having everything custom, every single experiment, every couple of months, you have a new experiment, is that you can't really automate. And my role was to automate. We're getting a new laser, which instead of shooting every 20 seconds, it now shoots at 10 hertz, 10 times a second. And if you just have a look at this, targets get absolutely obliterated when you get shot by a laser, by a petawatt laser. They basically get turned into high energy plasma. Again, I had nothing to do with that. I had to do automation for a custom target every couple of months. And I spent a lot of my time trying to figure out how to automate something that never stays the same. The production of something that never stays the same. And the reality was that I didn't really have anyone to tell me that solution. It was very much, I realized as I was on placement, that no one was gonna tell me the solution. I was just there stuck in limbo, waiting for someone to tell me, what am I supposed to do here? Well, I had to figure that out. And that was a big part of my placement. And I, at some point, figured the best way to do that was something like this. We have a lot of foils, basically shot, multiple layers of specific materials, whatever, it doesn't really matter. But putting them on an array like this, this is about this big. All of our small these are all small targets on there, small foils that get shot individually. And every time you shoot, It's an experimental run, and they have diagnostics to try and figure out what was happening when they shot the laser. So yeah, so the reason, oh great, Google not formatting. The reason why my placement role was there, because again, we have a new laser that's being built, and that's now working way faster than the previous ones. And we really needed to make, we previously made these under microscopes, and now we need to automate that. And if you actually do the math on that, that gives you like 36,000 targets an hour, which is absolutely insane, considering, again, these were manually assembled under a microscope. So basically, I worked with a robot cell. You can see that in the top right corner. That was a robot I was given. And I had to figure out how to automate putting these little foils here onto an array and glue them on, and then try and figure out whether they're flat or not. Here's actually where I worked on a day-to-day basis. I was in a clean room, and on the right you can see my final setup with the robot arm on the right that would pick up foils and put them on the array itself, and the array would have glue on it. And actually, most of my time was just spent trying to figure out how to use these robots initially. Yeah, and so then let's talk a little bit more. I've just talked about what I was doing. Let's talk a little bit more about actually placement itself, and what it means to be in science. Because at first I was like, that's not for me. I have nothing to do with science. Why would I even? But the fun thing is, you're going to be working with chemists. You're going to be working with physicists. You're going to be working with people who have very specific jobs completely out of robotics. And one thing that really I got from this experience was explaining robotic concepts to people who have no idea about robotics. And that was actually one of the challenges. I needed this system to be used by scientists who have no idea about robotics, and it just needs to run. So I spent a lot of time designing a control interface for it. So programming. I also designed, a control system for it. I designed custom processes for calibration of these robots. Will you load this one? Oh yeah. I also came up with custom production methods. This itself was a new approach to cutting these targets out by leaving it attached to the main foil and then tearing them out when they were picked up by the robot itself. And again, you're going to find really weird and funky things, problems that you need to solve. What you're going to find in any industry, and this is not specific to science, is that no one really knows what they're doing. So that kind of gives, I know Dan mentioned that at the end of the placement, you're like, I'm the robotics expert, this is what we're going to do. That makes sense. That doesn't make sense. That definitely doesn't make any sense. We should be doing this. And you more and more throughout your placement, you realize that you already have a really good base of knowledge, and you're going to be working with people who work in management. You're going to be working with people who are working, again, in other complete fields. And understanding that you are actually an expert is something that is going to come throughout the placement, something that you're not going to find in the lecture theatre. Yes, that's just stuff. Sorry, this is my end of year placement slide. And you're gonna have to work together with other fields a lot. Again, management. I had no idea that micro forces could act on these little foils, but apparently you can't just pick them up. Some weird, funky stuff happens, and I had no idea about that. And I had to have a scientist explain that to me, and then go back and actually say, okay, explain to them how I would actually pick it up, because they don't know anything about picking up, and I don't know anything about the science of it. So actually, you're going to learn a lot about collaborating with other people as well. Whatever. Okay, so that I already touched on the first point here. It is very fun to work with people in other fields. You're going to be having that a lot. Depending on the role, it obviously very much depends on whether you're in a niche robotic environment. I was certainly not. I was dealing with scientists and management, and that tends to be more the case that people aren't just within their field. You're going to be having at least a couple of tasks where you'll be interacting with people who may not know what you're doing. So that's a skill that you're going to get. Both Dan and I worked in a government facility. Just so you're aware for that, it's a very slow-paced environment. Money is usually not the problem. There's very expensive things and not enough people to do stuff with. But it also means you're going to have less stress. It's going to be a little bit more relaxed and a little more fun. But it may give you a slightly different side to industry than what you might experience in real world. In the real world, you're going to have time constraints. It's going to be stressful. While in a governmental facility, the output for this specific for the Science and Technology Facilities Council isn't actual revenue or profit. They measure their success using high impact papers, which means the work is just very different to what you might find in industry. So just that's something you need to be aware of if you're going into a governmental job, that yes, you have plenty of money, so you don't need to stress about that, but it is slow. And then depending, again, I've already touched on the challenges, so I'm not going to go into that. Yeah. You're also going to find that some roles, my role didn't have a technical lead, and that was very specific, and I don't think you're going to have that. But my role didn't have a technical lead, which means I had no one to feed back to, no one to give me help with what I was doing. I was very much not in the engineering department. I was in a cross-departmental department. Now that changed. I made sure that changed after I left, but I would recommend, if you do go in industry, to make sure that you do have a technical person to feed back to, because this is a development opportunity for you, and you need a little bit of feedback as to how you're doing, whether you're doing things right. Again, you're gonna be realizing that you are already knowledge-wise an expert, but you're still developing a lot of skills, and it's nice to have someone to feedback that whether you're doing well. And then finally, should you do a placement? Absolutely. That's my personal opinion. I'm probably not going to go back into science just yet, just because I have seen it now and I want to try something else. And that may be for you the case. And that's a point I would like to hammer home is this is an opportunity, a free opportunity for you to just try it and have nothing depend on it. Your placement year doesn't count towards anything. You just need to pass it, which is fairly easy in itself. And you get the opportunity to just see how an industry operates. And if that's not your thing, you can go somewhere else. And without repercussions at all. It's a free ticket. And And this was actually for me just the first step. I now know how science operates. Now I could maybe go into more specifically cars or robotics and see how that works. And then if I go, oh, actually, that's not as fun as working for these guys, I might come back. But that's how I will do it. And I think it's a great opportunity to just get that experience in for free. The other thing is, employers really, I'm currently applying to graduate jobs, and employers really do like to see you having experience. You see that a lot more, that they want a specific amount of experience. A lot of jobs aren't, the ones that aren't graduate want 3 to 5 years, and your year in industry often already counts. So you're 1 year ahead of everyone else around you. And that can give you a really good advantage when you're actually then looking to apply later after uni. And then finally, apply now. I disagree slightly with Dan said, but these are all personal opinions. I think if you haven't started applying, apply now. It's never too late. Raghav and I applied last year very late, and we still got quite a few applications in. It's never too late. Just try, and if you get rejected all this year, I don't know what years you're in, but if you're say 2nd to 3rd year and you're doing a master's, you can do it again next year. You're going to get rejections. It doesn't mean that you're not good enough. It just means statistically there were 500 people applying to a role that only 2 people can get. That's simple statistics, and just don't take it as a personal thing. You're gonna get loads of rejections, but just try and apply to as many as possible. 1 to 2 applications, I would agree with totally per week is what you want to go for. I found specifically this year it more difficult finding places that I find interesting as opposed to when I applied to industry. That may be to do with COVID, I don't know. That's just an observation I've made, but don't despair. Even if you don't plan on taking a job or a placement, an offer, still apply. Still apply, because that makes it even better for you. You get more experience in actually getting interviews in assessment centers. And in the end, if you get an application, sure, you can say an offer, you can say no. And if you don't, you got more experience out of it. And you can actually ask companies for feedback. And a lot of companies will tell you why they rejected you. So you can improve on that. And I would also really, really suggest going to career service. I got my CV checked, I don't know, like 15 times at least. We kept on going back and getting it checked over and over and over again until at some point they said, well, I don't know, that's all good now. So we really recommend. They have more tools which are new this year, which are online. They have like a CV checker thing. And that does a lot of the automated stuff that big companies will just send your CV through automatically. So you can make sure that you definitely get passed through the first stage of just automatic sorting. And that's already really beneficial to you. Yeah.
If there's any questions for 3 of us, I know we didn't ask earlier, please.
Yes, yeah.
You come forward or ask away right now.
Yeah, actually, our question.
Is that trying to send us a message?
No,
This was already here.
It was there already. It was
mysterious.
nothing to do with us.
Yes. I mean, to be fair, I think there is truth to the fact that like the daily grind is not that thrilling. But then like you're probably at 2nd year or 3rd year now. And the daily grind of the last few years probably hasn't been thrilling either. So hang on. Yeah.
Do we have to apply for a job at the 1st year?
And 1st year?
No,
I wouldn't say so, no.
absolutely not. So these are opportunities that students tend to take between 2nd and 3rd year. if you do any masters, you can do it between your third and fourth year, depending on what department you're in. I know the Triple E department has recently changed its stance for the past years about whether which years you do it in. Now they're happy for you to do it between the second and third, or the third and fourth. Some companies may say in their applications that you need to be in your penultimate year. That means you need to be in your second last year. So then, yeah.
Depends if you're on the integrated masters or the bachelor, whether you're second to last year.
But it may be something that you need to consider. Yeah.
So what would you say the differences are in academia as opposed to industry?
Oh, is this an actual, like, when you say academia, do you mean university or like PhD?
PhD.
Okay, this is an actual SB question. I've only been doing my PhD for about 6 weeks, so I'll do my best. But it's complicated. I think the biggest thing is timelines and freedom. Those are the two things I would say. So like in the industry, you know, you've got a job and a boss and you have to actually deliver stuff like this week. And you know, people, if you don't show up to the lab for 3 days, someone will notice and be mad at you, right? Which isn't the case with PhD. You know, academia is much less structured. I meet with my supervisors once a week, which is a lot for a PhD. Min, who was here before, only met with his co-supervisor for the first time last week, and he's been doing his PhD for 3 months now. So you have to apply all the structure yourself. No one will notice if you don't come into the lab, especially in the post-COVID days when most people are working from home. It's all on you to make sure you're meeting whatever deadlines you set for yourself, because the nearest real deadline is 3.5 years away. And the other thing is that, the kinds of problems that you solve are very different. Industry wants to make money, and they want to do that soon. And maybe not like this year, you know, like Raghav talked about, iteration times are long in certain industries. But a lot of academia is like, we don't even know if this is going to go anywhere. And it's entirely possible that you could spend 3.5 years of your life working on something, and the final conclusion is like, yeah, this is a terrible idea. No one should do this. This is useless. But like, that's new knowledge that we didn't have before. So like, that is valuable, and you will get a thesis and a doctorate out of it. But it can be a bit soul crushing if that's not your jam.
There's actually then also the outcome, what you're actually trying to achieve.
Yeah, that's true. It depends what you want in life, I guess, and where you want to go. It's notable that PhD, is it even accurate to say that it pays less? Does it even pay? So I've got a stipend, which is not guaranteed. And my stipend is, legally speaking, not paid, because if it was, it would be lower than minimum wage. And if I had taken my job offer at Sellafield, I could be earning £20,000 more a year. But instead, I'm here. Yeah, it depends where you want to go. If career advancement is on your mind, I wouldn't recommend academia.